grade. Welcome to day 5 of week 7. Today is May 8th. Just going to take you through what you are responsible for today. If you noticed, some of you, I had posted a link to give you a preview as far as what we're going to be covering today. Hope that some of you looked at it. If you have not, please look for that on the stream. It says it's about 7 minutes, but some of you might be able to fast forward through and then get to the what the point of the video is to show you exactly what we're focusing on for today's lesson. Okay, so we'll click on the classwork. I'll go down to week 7, day 5 right here. So you have your lesson. The same link that I posted to the stream is here for you to use as a support. Click on the lesson. Okay, so our warm-up says to answer the 2 questions. When do you use elimination with addition and when do you use elimination with subtraction? So at this point, you guys should know that we use elimination with addition when we have opposite coefficients because they are additive inverses and they sum to 0, which is why we use that, because then it eliminates that variable. And then we use elimination with subtraction when we have the same coefficients, because if you have the same numbers and you subtract them, their difference will be 0 to eliminate that variable. Okay, so the answers are here, like I just went over. And like I mentioned earlier, we are going to be doing elimination still, but now we're using multiplication. So in some linear systems, neither variables can be eliminated by adding or subtracting the equations directly, meaning right away. When you look at the system, you might not have the same or opposite variables, coefficients I should say. So in systems like those, you need to multiply one or both of the equations by a constant so that adding or and subtracting the equations will eliminate one of the variables. Okay, so when you multiply one of the equations, it does not change the value of the equation. I'll show you that right here. Let me just open up my marker. Okay, so for example, if I gave you the equation 2x plus 4 equals 10, could you tell me what x equals? 2 times what number plus 4 equals 10? So in this case, x equals 3. Okay, because 2 times 3 is 6 plus 4 equals 10. If I was to take this entire equation and multiply it by 2, let's say, right? So now I would get, okay, this would be 4x, this would be 8, and then 2 times 10 would give us 20, right? If I was to solve this equation, what do you think x is going to equal? 4 times what number plus 8 equals 20? Well, guess what? Even though we multiplied it by 2, x is still going to equal 3, because as long as we multiply every single term in the equation by that constant, it does not change the value of the equation. And that's the understanding we're going to use for when we get systems that do not have those same and opposite coefficients right away. Okay? So we'll do our first example. So looking at this system, if we look at our x's, 2 and 3 are not the same and they are not opposites, and 10 and -5 are not the same and are not opposites. So in these types of systems, I want you to think, can you multiply one of the equations by a certain number to make the same or opposite coefficients? So could you multiply the top equation by a certain number so that the x's and y's match up, or could you multiply the second equation by a constant to make the variables either the same or opposite? So it seems like a little weird to say. I know that even me saying it, I feel like it's a little confusing, but when you see it, I think it'll be much easier. So we're looking to see what can I multiply either the top equation by or the bottom equation by to make these coefficients the same or opposite. So I know that 5 is a factor of 10, right? And if I multiply this -5 by 2, it'll give me a negative 10, and then my coefficients of y's will be opposite, so I would be able to eliminate it through addition. So I'm going to now take my entire second equation and multiply it by 2. The entire thing. So you're going to use the distributive property to rewrite that, okay? So we would do 2 times 3x, 2 times negative 5y, and 2 times negative 17. So our top equation stays the way it is. I'm going to rewrite it because we don't change anything with that top equation. We chose to change the bottom. Okay? Now, after I multiply this entire second equation by 2, let's rewrite what that would be if I took this equation and I doubled it. So 2 times 3x would give us now 6x. 2 times negative 5y gives us negative 10y. Bring down my equals. And 2 times negative 17 will give us a negative 34. Now, looking at this system, I notice that my coefficients are opposites, and now I can use the process of elimination with addition. Okay, so you guys are already comfortable solving these. We practiced all this week and started a little bit last week, I think, on elimination, so you should be comfortable with this. So at this point, we would make our vertical lines down, right? We would get 2x plus 6x, I'll write that here. And 2x plus 6x would give us 8x, okay? 10y plus negative 10y. That's going to give us our 0, so our y's are eliminated, okay? And then over here we have 2 plus negative 34. And that would equal negative 32. Okay, so we're back to where, to some familiar steps. I know you guys were doing this in your work that you showed me all week. So we rewrite it without the 0. So 8x equals negative 32. And then we simply divide by 8 to get x alone. And we'll get x equals negative 4. Okay, so the only thing that's different is this top step, looking at the system and trying to figure out, okay, what can I multiply one of these by so that I can then use addition or subtraction with the elimination method, okay? So that's where the difference is. Everything else shown down here, you guys have been doing all week, and you've all been doing pretty well with it too. So, you know, I think just keep doing what you're doing because you're getting it. We're just adding on this additional step now. Okay, so we have x equals negative 4. We're going to use one of the equations. It doesn't really matter which one because they're both a little complicated. I think I'll use the top one though. So I'll rewrite it over here. 2x plus 10y equals 2. I'm going to plug in my value of x, which is negative 4. So 2 times negative 4 plus 10y equals 2. And then we simply solve our equation. So 2 times negative 4 is negative 8 plus 10y equals 2. I'm going to add 8 to both sides. We'll get 10y equals 10. And then we divide by 10 on both sides. And we'll get y equals 1. So then our final step would be to just write it as a solution. So solution, parentheses, x, so negative 4, comma, y, 1. Okay? All right. So everything I modeled is also in the lesson. I'll show you it right here. Okay? If we keep going, you'll see the solution, right? We got the same thing. The steps that I just took you through are right here. So the yellow highlight is look at the system, figure out that number that you're going to multiply by to get the same or opposite. I will recommend that I think it's much easier to make the coefficients opposites because then that means you're adding, and I just feel like adding is so much simpler for you guys. You don't need to worry about keep, change. So keep that in mind. You're going to always look for the coefficient to multiply to make them opposites, not the same. Okay, I mean, you can do the same. I just feel like students make more mistakes when they're subtracting. They forget to do a keep, change here or there, and then it causes them to get the wrong answer. So my suggestion would be make them opposites so that you can add. Okay, you then are going to multiply the entire equation using the distributive property. You're going to rewrite it, and then all these steps are the same we've already done. So I'm not going to repeat myself for that. Okay. So we'll go on to the next one. I'm just going to erase my board so that I have room. Okay, let's see. So our equation, our system this time is x plus 10y equals 3. And then we have 4x plus 5y equals 5. Okay, so we're going to look at this system and say, what number can we multiply one of these equations by so that we get the same or opposite coefficients? Because right now we don't have them, right? The coefficient with x is 1. We know there's really a 1 there. We just don't always write it. And 1 and 4 are not the same or opposites. 10 and 5, they are not the same or opposites. So we need to figure out what can we multiply by to make them the same or opposite. And I think this time I'm going to change the top equation. Now, there are different ways you could do this. Okay, I'm just choosing to change the top one. I'm going to multiply the top equation by -4, because when I multiply the top equation by -4, my x's will now be opposites. So I'm going to put parentheses, put -4, and then I'm going to multiply every term in the first equation by -4. Okay, so -4 times x will give me -4x. -4 times 10y will give me -40y. And -4 times 3 will give me -12. So some of you might have wanted to multiply the bottom one by 2 to make these 10s match up. You could have definitely have done that too. I'm just choosing to do the -4 instead, okay? I'm now going to take my second equation and rewrite it underneath because I didn't do anything to that one. And now looking at this system, my x's are opposites. So since my x's are opposites, or additive inverses, we can add our system to eliminate the x variable and solve for y, okay, which is what we're going to do. So draw your vertical lines down, okay, and we'll get started. So we have -4 plus 4x. Okay, that's going to equal our 0. That's why we're doing this, to eliminate the variable. Then we'll do -40y plus 5y. So -40y plus 5y is -35y. And then we'll do -12 plus 5. And -12 plus 5 will give us -7. Okay? We'll rewrite it without that 0 because we don't need it. So now we're left with -35y equals -7. We'll divide by -35. These will cancel out. We'll be left with y equals, if we were to divide this, we would get a positive 1/5 or a positive 0.2, depending on if you keep it as a fraction or a decimal. Okay, so I don't think on today's exit ticket you get rationals for your solution, but you can, so don't get nervous. Sometimes they do come up, but I don't think on today's assessment, today's exit ticket, there are any. So if you do see a rational, I would say maybe check your work again. All right, so then we're going to take one of the equations and we'll plug in 0.2 for y. So I'm just going to see which one I do in the lesson so that it matches with my model. Okay, so I took the second equation. Okay, so I'm going to rewrite that over here. So we have 4x plus 5y equals 5. I then am going to take what I solved for y, which was 0.2 or 1/5, it doesn't matter, and we'll plug it in for y. So I'll have 4x plus 5, we'll put the decimal form, okay, equals 5. Okay, so then we have 4x plus 5 times 0.2 will give us a positive 1 equals 5. And then we solve our equation. So minus 1 to both sides. 4x equals 4. Divide, ooh, I got sloppy. Divide by 4. And x equals 1. Okay, so we solve for our x, we solve for our y. The last thing you have to do is write it as a solution. So we write it as our coordinate. X comes first, so 1, comma, 0.2. Okay? All right. So I think there might be one more question for you. Yeah. So there's one more question here. It takes you through different ways you could solve, and then you have your 4 questions today to do for extra practice. So like usual, you have the work document. You can send that to me using any of the options provided, and then you have your Google form where you'll answer the same questions just in a Google format, the Google form format, I should say. Okay. All right, guys, I hope that helped. If you have any questions, feel free to reach out to me. I'm always available to help you between 7:40 and about 3:30 every day. Have a good weekend.